Hi guys, we are going to be talking about the 2015 AP Calculus AB FRQ. We're going to be focusing on question number 4 since it's a differential equation. So personally, I really enjoy solving differential equation problems because they're kind of like a puzzle, and usually they'll have a slope field like this particular problem, or they'll have you draw something, and I think that's super interesting all the time. This is a bit of a refresher since we have not done differential equations since January, and I guess in the beginning of which is the beginning of BC, and towards the end of AB, we started it. So the thing with differential equations to make sure to remember is that this isn't the formula, it's the first derivative of something. And usually with differentials, they don't ask you to find the original function, they just ask you questions like based off of the derivative. So we are going to go ahead and start with the first part, which is slope field. So College Board usually asks to draw a slope field, and they'll give you 6 points to do it. So here we have like 1, 1, 1, 2, whatnot, right? So a lot of the times, you can do it like in your head, like mental math, but personally, I'm not the best at mental math, so I usually make a table, so like x, y, and then dy over dx. So the first point is 1, 1. So I just first put the points. I know it's 1, 1, 1, 2, 0, 2, 0, 1, 0, -1, and 1, -1. So then I basically just plug in all the points here. So for the first one, I get 1. For the second one, I get 0. Oops, sorry. Third one, I would get -2, -1, 1. This one, I would get 3. So the thing with slopes field is you basically kind of like draw like a line similar to slope. So since the first one is 1, here on this point, I'll draw a line that has a slope of 1. So that's positive, so like that. So then the second is 0, and once it's 0, we know that it's just a horizontal line, because when you have a slope of 0, it's essentially a horizontal line. Second is we have 2 slopes of negative. So when it's negative, it's essentially just the other way. Then another negative, and then a +1, and then a +3. So usually College Board will take off points if like the slope field isn't like the slopes are like look the exact same. So here with 3, I tried to make it a little more steeper, and then here with -2, I made it a little more steeper than it should be, because just we want to make it more obvious. The second question is asking about the second derivative, and then to determine the concavity of all solutions. So let's start here. Let's do it right here. So since we already know the first derivative up here, this is just easy. You do a bit of implicit differentiation. So I'm going to put dy over dx equals to 2x minus y. So the second derivative would just equal to 2 minus dy over dx. And here we can essentially just plug in 2x minus y. This is equals to 2 minus 2x plus y. So now we have to find the concavity of all the solutions in quadrant 2. So concavity basically is like if it's like up or down. So that's usually found in the second derivative. So with College Board, they'll kind of trick you, because like obviously like we all know how to find concavity when we're like given the first derivative or the second derivative or just the function itself, and we know how to find the concavity. But with differential equations and stuff, people usually like trip up and they're like, oh, I don't know what to do, but we do. We have the second derivative. So in quadrant 2, in quadrant 2, we know that x is less than 0, and we know that y is greater than 0. Therefore, we can say 2 minus 2x plus y is greater than 0. And it's when we know when its second derivative is greater than 0, we know that it is concave up. So check. So basically, this is kind of our reasoning. You can make it a little like nicer, if you will. You can say like, because x is less than 0 and y is greater than 0, therefore this must be less than 0. So now let's go to C. C is asking, let fx be the particular solution to the differential equation with the initial condition of f2 equals to 3. So with this, we basically just plug in 2, 3 for 2x minus y. So I'm just going to do that. So here, when we plug it in, we get 2 times 2 minus 3, which is just 4 minus 3 equals to 1. So we know that, so then we have to find if it's a relative minimum, maximum, or neither at x equals 2. So when we have a relative min-max, that basically means when the first derivative is equal to 0. This does not look like that it's equal to 0. So we know 0. So there is neither. Okay. So then the last question is asking, find the value of the constants m and b for which y equals to mx plus b is the solution to the differential equation. So I'm going to bring up my notebook here so that you can see. So the first thing I'm going to do is I'm just going to write y equals to mx plus b. So now we're just going to find the derivative of this. So dy dx equals. So then this. So you might be thinking, dy over dx, how do we know this? Well, look, it's just the equation they give us, 2x minus y. So then we basically bring everything to one side, 2x minus y minus m. So we know that y equals to mx plus b. So it's just very mx minus b minus m equals to 0. So I take x out, so 2 minus m is to negative b plus m equals to 0. So when you know when x equals to 0, 2 minus m equals to 0, so that just equals m equals to 2. So we know b plus m also equals to 0, so that just b equals to negative m. So we know that b equals to negative 2. Oh, yeah, b equals to negative 2. Sorry, I made a mistake. So then we basically just plug it in, 2x minus 2. And that's basically part T. So essentially with differential equations, a lot of practice on FRQs can help, and College Board tends not to ask a lot of differential equation problems just because a lot of like students kind of forget about them or not, but College Board can trick you and like give you an equation and then make you do separation of variable, which this problem didn't, but they'll trick you with like wording with like separation of variable so you don't know. And then they can ask you about like concavity like they did here, or like relative min or max, or essentially anything you've done before back in AB like with derivatives and how like the function affects like the graphs and stuff can be asked here, because it's essentially just the derivative, so it's not like they can't trick you. Or they'll give you an already drawn sketch field and they'll make you draw like a solution to that. So my best advice is do practice problems in the book. I'm blanking out on what chapter. I'm pretty sure it's chapter 9, I want to say. And just getting really a good strong derivatives and integration, because for separation of variable they could ask you to do that, and that's integration essentially. But the biggest thing is just make sure you look at the wording, what they're asking for, and not get too freaked out, because just imagine it in a scenario of derivatives. And yeah, that is question 4 from 2015 AP Calc AB FRQ. Thank you.